So next we have uh, Barton reaction. This is one of the simple reaction, so in examination point of view it's very important. So uh, there should be a compound like this, okay, and at a delta carbon, this alpha, beta, gamma, delta, there should be two hydrogens. Then only Barton's reaction is possible, otherwise it's not possible. If we have this kind of compound R, so in this case Barton reaction is not possible. Okay, so in the first step the cleavage of nitrosyl group takes place and it forms a radical here, and from the delta carbon the hydrogen will shift from here to oxygen, and this will be a OH and this will be a radical. Now the NO which is there in the reaction mixture, that comes and attacks to this carbon, so that we get a NO. Okay, and one more hydrogen is there, so now this hydrogen shifts from here to onto the oxygen, and it leads to form double bond NOH. So this is the final product in the Barton's reaction. So it's a very simple reaction, you just need to remember the mechanism. In the first step there is a cleavage of oxygen and nitrosyl bond, and there is a formation of free radical. Now from the delta carbon, one hydrogen migrates from delta carbon to onto oxygen, it leads to form OH, and there is a radical, and that radical will be attacked by the nitrosyl group, and then hydrogen migrates from here to there, then we'll get this compound. So there are some other examples we have. I think this is above the plane, and this should be, take this is a below the plane. So now this is alpha, beta, gamma, delta, so here the nitrosyl group, this ONO is, nitro group is below the plane, but this chain, this carbon chain is above the plane. Sorry. So now the hydrogens from here, this carbon will not be shifting from here to here, because this is present below the plane, and below the plane, this is above the plane. So because of that, this will not involves in the Barton's reaction. So this carbon will involve in the Barton's reaction. So here the product what we will get is, I'm directly writing the product. So this is the product here we'll get, and it will be clear if you write this one in this form. This also can be written like this, so NO, and this is hydrogen, and at this carbon we have this long chain. Now alpha, beta, gamma, and this should be delta, and these two hydrogens are, one will be above the plane, another one will be the below the plane. Okay, so I think this is clear, right? So this is gamma, so from here the hydrogen will takes place. This is only this same structure we can draw like this also. Then we have ONO here, and here we have a methyl group. See, now this is alpha, beta, gamma, delta, gamma, delta. So here also two hydrogens are there, and here also two hydrogens are there. So which carbon will involves in the Barton's reaction? Just remember, in this case this is on the plane, sorry, below the plane, and this is on the plane. Okay, because these two are in a opposite direction, but here this is above the plane and this methyl group also above the plane. So because of that reason, this methyl group involves in the reaction. The product will be CH2 and double bond OH. So this will be the product. So if it is a below the plane, like so this is above the plane, and if it is a below the plane, in this case this position will involve in the reaction, and the product what we'll get it here is this will be OH, this will be N OH. So this will be the product here. Okay, next we have yeah, this is also one of the important. This is methyl above the plane and ONO and methyl. See here we have alpha, beta, gamma, delta, alpha, beta, gamma, delta. So both the, see here, both the methyl groups are equal distance. Okay, so this is separated by this ONO and methyl group separated by one carbon, and here also this ONO and this methyl group are separated by one carbon. So in that case we'll get a mixture of products. So imagine this is the first product. Here double bond NOH, and this will be plus. The second product will be NOH, and this will be a methyl group. So in this case mixture of products will form because ONO is having equal distance between the both the methyl groups. Then we have another example where we have this kind of arrangement. Here we have ONO above the plane, now so here two possibilities are there, either this can involve or this can involve. Alpha, beta, gamma, delta, alpha, beta, gamma, delta. Okay, so in this case the product what we will get is yeah. So because of like wait OAC and CH double bond NOH, this product. So here also this ONO is separated by the one carbon. So here also we'll get a mixture of products. No, not mixture of products. So this is the first product, and this methyl group also involves in the reaction. This methyl group also involves in the reaction, but the product what we will get is different. So that product will be like this because of this double bond. So imagine that here this free radical we have. In the first step we have a OH, and this free radical we have. Now this bond also breaks, and here radical, and this is also radical. Okay, now these two forms a bond here, and NO attacks here. Okay, so the second product what we will get is here. This one is the second product. The first product is this one, and the second product is this one. So because of this double bond, so this methyl group undergoes it forms a cyclopropane ring inside the ring. Okay, this is about the Barton's reaction. This is one of the simple reaction. So here we need to see the stereochemistry. So where this NO group is present, or NO2 group is present. If this is present, NO2 group is present above the plane, and this should attracts the means like if it's present above the plane, and there should be some methyl group which has to present above the plane. If no above the plane means we can go for the on the plane where the carbon is having a two hydrogens. So this is about the Barton's reaction. So this is one of the simple reaction. You can score as much as many marks from this reaction. In the examination point of view also, it's very important. I think in the GATE exam, they mostly every alternative year they will be asking a question from this Barton's reaction. I think last year they have asked a reaction in the GATE exam, okay, question like this. Like this they have asked question in the GATE exam, and this is also simple. So this alpha, beta, gamma, delta, the product what we will get it is here OH double bond and OH. Okay, so you can score marks easily from this reaction. So if you have any doubts about this about this lecture, you can write in a comment box. Thank you.